Imagine being able to solve complex problems in seconds, problems that would take conventional computers centuries to crack. That's the promise of quantum computing. But what practical uses does quantum computing really have? Welcome to the world where the boundaries of computer science are being pushed beyond imaginable limits. We're talking about quantum computers, machines designed to perform specific tasks at breathtaking speed, surpassing any classical computer. Back in 2019, Google claimed a quantum advantage for its Sycamore processor. But the challenge remains: finding real-world applications for these abstract quantum speedups. So, Google and XPRIZE took a step, launching a $5 million competition to find practical uses for quantum computers, uses that could benefit society. They are urging researchers to create new quantum algorithms, a 3-year contest that could potentially revolutionize how we approach problem solving. So, the question we pose today is, how can we harness the power of quantum computers for practical, real-world applications? Before we dive into the competition, it's essential to understand what quantum computing is. At its core, quantum computing is a type of computation that harnesses the unique properties of quantum mechanics to process information. Unlike classical computers that use bits, ones and zeros, to process data, quantum computers use quantum bits or qubits. Qubits can exist in multiple states at once thanks to a property called superposition. This allows quantum computers to process a vast number of possibilities all at once, potentially solving complex problems at speeds that would be unimaginable for classical computers. However, quantum computing isn't without its challenges. One of the main issues is that qubits are incredibly sensitive. Even the slightest disturbance can cause a quantum computer to make errors, a phenomenon known as decoherence. In 2019, Google announced a significant breakthrough. They claimed that their quantum computer, named Sycamore, achieved quantum advantage. This means that Sycamore performed a specific task faster than the world's best classical computer could. The task was essentially a complex mathematical problem, and while it didn't have immediate practical applications, it demonstrated the potential of quantum computing. Despite this achievement, there's a gap between what quantum computers can do in theory and what they can do in practice. Many of the problems that quantum computers are good at solving are abstract mathematical problems. While these problems demonstrate the speed and power of quantum computing, they're not necessarily linked to real-world applications. The research community has been striving to connect these abstract quantum speedups to specific real-world applications. They're trying to figure out how quantum computers could be used in ways that would benefit society, not just solve complex math problems. Despite the immense potential, we're still in search of real-world applications for quantum computers. That's where this competition comes in. Google and XPRIZE are challenging researchers to come up with new quantum algorithms that could benefit society. Picture this: a global contest, stretching out over 3 years, where the brightest minds in the world are invited to delve into the world of quantum computing, to explore its potential, and to push its boundaries. Here's the crux of the competition. It's not about solving abstract mathematical problems faster, it's about finding practical uses for quantum computers that could make a real difference. Google and XPRIZE are not merely looking for speed, but for impact. They are seeking quantum algorithms that could solve existing problems, like finding a new battery electrolyte that could revolutionize energy storage. But it's not all about creating new algorithms. Participants could also show how an existing quantum algorithm could be applied to a real-world problem not previously considered. The competition is as much about innovation as it is about application. This opens up a world of possibilities for researchers to explore and exploit. The rules of the competition are clear. Participants don't need to solve the problem in practice. Instead, they need to detail how an algorithm could be applied, specifying the exact quantum computing specifications required. It's about demonstrating potential, showing how quantum computing could be used to make a difference. This competition is a call to action for researchers around the world. It's a challenge to think outside the box, to apply quantum computing to real-world problems. The winning algorithms could potentially pave the way for breakthroughs in various fields, from healthcare to renewable energy, from climate change to cybersecurity. So, let's see what the world's brightest minds can come up with. Let's see how they can harness the power of quantum computing to benefit society. Let's see how they can turn theoretical potential into practical applications. It's not about solving the problem in practice, but showing how an algorithm could be applied in a real-world setting. This is the quantum computing competition, and it's going to be exciting. Now you might be wondering, how will the entries be judged? And what impact could these algorithms have? Well, the judges of this quantum competition have set out a range of criteria for evaluating the entries. First and foremost, the potential impact of the algorithm is a significant factor. The judges will be looking for algorithms that could potentially change the world, solving problems that have been plaguing humanity for years or even decades. It's not just about speed or efficiency, but about making a tangible difference in people's lives. Another crucial criterion is alignment with the United Nations Sustainable Development Goals. These 17 goals set by the UN aim to create a better and more sustainable future for all. They tackle global challenges including poverty, inequality, climate change, environmental degradation, peace, and justice. The entries that can address these issues in a meaningful way, leveraging the power of quantum computing, will certainly have an edge in the competition. Finally, feasibility is key. It's all well and good to create an algorithm that could theoretically solve world hunger. But if it requires a quantum computer the size of a planet to run, it's not going to be much use. So the judges will be considering how feasibly the algorithm can be run on machines available now or in the near future. This includes not just the raw computational power needed, but also the practical aspects of implementing the algorithm in real-world situations. In essence, the competition isn't just about showcasing the power of quantum computing, but about demonstrating how it can be harnessed for the greater good. The entries will be judged not merely on their technical merits, but on their potential to make a positive impact on the world. The potential for large-scale impact is immense, particularly if the solutions align with the United Nations Sustainable Development Goals. The race is on to find practical uses for quantum computers that could revolutionize various fields. We've explored the depth of quantum computing, the massive $5 million competition launched by Google and XPRIZE, and the potential impact of this groundbreaking technology. The power of quantum computing is astronomical, and it's exciting to think about the ways it could reshape our world. This competition is a call to researchers worldwide to think outside the box, to envision how quantum algorithms could be applied to real-world problems. The possibilities are endless, from revolutionizing energy storage to tackling global issues that align with the United Nations Sustainable Development Goals. So, stay tuned as we follow this thrilling race closely. The next few years are going to be a roller coaster ride in the world of quantum computing, and we can't wait to see where this journey takes us. What are your thoughts on the potential uses of quantum computers? Share your thoughts in the comments section below. Don't forget to like, share, subscribe, and turn on the notification bell to stay updated. Until next time, keep imagining a quantum future.